How are you, everybody who is watching this video? My name is Olenjolai. If the first time to meet you, I would like to take this opportunity to welcome you into this fantastic moment of learning the beauty of electronics and telecommunication engineering. I have some local students who have joined me in this class. Today I'm going to teach you about electronics product fabrication. Actually, in order to fabricate a particular product in electronics, we have always to think about designing or a particular problem and then to impose the solution. So this is workshop what? Workshop 3 or workshop what? 3 or 4? 3, eh? It means that Saturday was 4. Workshop 3? I think so. Yes, workshop 3. So this is workshop 3. So we've done workshop 1 and workshop 2. In case that you've missed it, you have to go through them. And today, the main purpose of this workshop is designing the linear power supply. So I want to ask you right now, take your pencil, take your paper or your drawing papers, and then take your ruler, take all the drawing tools that are important, take the fresh mind, let us go to the business. But before we start our class, let me introduce my local students who are studying or are bachelor in electronics and telecommunication engineering at the Dar es Salaam Institute of Technology. Good morning, class. Good morning, sir. How are you? Yeah. Are you ready to learn designing the linear power supply? Yes. Good. So here it is, workshop 3. So designing a linear power supply. Designing a linear power supply. So why do we need class? Why do we need to design a linear power supply? Or the main objective? The main objective is in order to use this linear power supply in order to provide power in different subsystems of a particular electronics system or subsystem. That's the main purpose. So it means that we say most of electronic systems or electronics devices works by using particular amount of power. So this one will be supplying power to the different parts. It's just like a mobile phone. It needs a battery in order for it to work. Just like a computer, it needs a battery. If it is laptop, it needs a battery in order for it to work. If it is desktop, it needs AC because for the desktop, they're using domestic power. But within it, also that power should be converted into direct current because it's alternating voltage. But another advantage, we want to use the domestic power that we have elsewhere in order to power our designed electronic product. Okay? Okay? So, you remember that in workshop 2, I taught you about how can you open the single block of linear power supply and come up with the general block diagrams or detailed block diagrams of linear power supply. And then we say the first block is what? We say that we have a step down transformer. But I told you that this is not a unit. Okay? If you have one component, we don't call it a unit. A unit should consist of more than one component. Right? Then once the step down transformer performs its responsibility, then it delivers the output to the another block. And this block is called the rectifier. Rectifier what? Rectifier unit because it consists of more than one component. Right? Then the next block, once the rectifier performs its responsibility, then deliver or it provide the outputs into the filter unit. Again, we say that once the filter unit filter the DC or the unregulated DC power, then it deliver its output to the voltage regulator or voltage regulator unit. And once it performs the responsibility, then we have the last block, which will be consuming the power from the linear power supply, which we call T load. So what are we going to design? Actually, this is all about the linear power supply. Are we together? Are we together? Are we together? Yes. So we don't design a load because a load, it can be either a circuit or it can be maybe a particular device or it can be something else that needs this power supply from the linear power supply, or needs electricity or needs electric energy, and especially direct current energy or DC energy from the linear power supply unit. So this is a detailed, we call it detailed class. This is detailed block diagram. Detailed block of linear power supply. Nura, concentrate please. So that's what we have discussed. I have taught you that how do you open the single block and come up with this one, because the single blocks is actually used to call it power supply unit. So so remember that I told you that, or let me just write this one, take a note. In electronics, we have three types of 40. So this is the note of power supply. We have three types of power supply. The first one, namely what? The first one, we call it DC power. Class A, DC power supply. So even online students say DC power supply. So the DC power supply, actual that, you find the main source is DC. It's not AC, right? But also, this is the simplest power supply. Its disadvantage, you might use a unrechargeable battery. So once the power it has been consumed from the main source, which is the battery, then you have to throw it away and go and buy the new one. That's the disadvantage, right? Are we together? Yes. Then the second one, we call it linear power supply. So it's linear power supply. Sometimes we call it AC to DC, linear power supply. Linear power supply. So with this one, the main source of power is AC, which is domestic alternating current, right? The third one, which is actual, it's a commercial for the commercial purpose, is called this. It's called what? It's called the switched. Say switched mode. Say switched mode. So switched mode power supply. Switched mode power supply. Also, this one, it's converting AC to DC. The difference between switched mode power supply and AC to DC linear power supply is just the configurations of the circuit. In linear power supply, we just use the voltage regulator to regulate the voltage. But in case of the switching mode, we have to use MOSFET transistors in order to switch the power. And that's another story. So this is the simplest, this is medium, and this is a little bit challenging. But most of the adapter, whether it's mobile phone adapter or mobile phone charger, or maybe a computer adapter, most of them, whenever that, it means that, for example, the power supply within the TV, maybe iPad adapter. So most of the adapter, whenever you hear something about adapter or a charger, they are switched mode power supply. There are advantages of having linear power supply and disadvantages. There are also advantages of switched mode power supply over the linear and DC, and disadvantages. But switched mode power supply has been found that it has many advantages more than other two types of 40 power supply. So for the commercial purpose, we use switched mode power supply. So even if you take the mobile adapter like this one, because this is all about what is actual supplying power. The cable, the USB cable, is just transferring power from here to the load, right? So if this one, we say that it consists, if for example we say that within this head of the mobile charger, there is a linear power supply. So actually this one will represent block number 1, 2, 3, and 4. So your mobile phones, or for example that the USB or the cable, right? So it's just from here to here. And this one is your mobile phone. Or this one is your laptop. Or this one is your computer. Or this one is your iPad. Are we together? Are we together? But I told you that the type of the power supply which has been used in this mobile charger, or mobile charger, or mobile adapter, you can call it, is fine. It's a switched mode. Right? Why? Because switched mode has so many advantages over what? DC power supply and linear power supply. But now, for the purpose of learning and for the purpose of electronics prototypes, and also for the purpose of imposing and training students how we can convert AC into DC, this is the case that we have to teach. And in most works of electronics, we are using this linear power supply rather than switched mode power supply. But it should not be limited. You have to master this. Once you master this one, then you have to learn this one after a period of time. Because learning this one, don't think that it's easy. You might design your linear power supply and test it on the breadboards or maybe on the variables on the PCB board, and then it's not working. So you have to troubleshoot over it. Are we together? Okay. So when you say we are designing a linear power supply, so we are going to open each block and come up with the schematic circuit symbol of those components which are consisting of join together or function together to form the block. Are we together? Are we together? Class, are we together? Yes. What's the name of the first block? Eh? Again. 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 I don't hear you. Again, speak it loudly. Do you like this stuff? The answer is yes. So, speak them loudly. Say step down transformer. Step down transformer. Yes, because whenever you pronounce, you keep in your mind. So listen, let me teach you the brief concepts of step down transformer. And then we'll go and open the other blocks. So simply, we say that a step down transformer is electrical device which step down the AC power. So that's the simple meaning of 40 of the step down transformer. So the main responsibility is step down the AC power. It cannot step down the DC power, cannot step down maybe the AC power of the high voltage rather than maybe its capacity. So simply say that actually it step downs the AC power. Okay? So to narrow the concept, because we are focused on designing and especially on the applications of mathematics, because we said engineering is all about numbers, formulas and equation, diagrams, tables and graphs. So we say that in electronics engineering, there are different low power step down transformer of different capacity and the size. So if you notice what I told you in previous, I did not say these sentences. That's why I told you that you have to rewrite. Right? So just refer what you have written last time. I didn't say that sentence. So I'm going to add some material and I'm going to remove some materials. So he said in electronics engineering there are different low power. Say low power step down transformer. Low power step down. We have high power step down transformers. Those are the ones we used to see in high grid or in TANESCO line, or used to see in different places where there is an integrated number of people. Those are high power step down transformer, right? But with the electronics, we are using low power step down transformer. The principle is still the same, but the difference is rating. Okay? Okay? Okay. So you say that the input. So let us just discuss about important electric parameters. Important electric parameters of 40 of step down of low power step down transformer. Step down what? Transformer. So important electric parameters of low power step down transformer. So the first important parameter is called the input voltage. Input voltage. Say input voltage. Or simply we say that we may just call it input root mean square voltage. So he said that we have two. So input voltage. So he said that the low power step down transformer receive the input voltage of the input, the domestic receive the domestic input voltage of either either 1 and 10 voltage or 120 I told you to go out and then you are roaming around. So the input voltage might be either 110 volt or 220 volt to 240 volt. So these different input voltage depend on the domestic root mean square voltage. In United States of America, they are using 110 volt. That's the domestic power in United States of America. In European countries, and especially in British, or let's say in England, and including most of the countries in Africa, all the countries of Africa, we are using 220 volts to 240 volts. Okay? Okay? So this we call it the input because we began with the input. So this is just, you can say that, input of the transformer. So the first parameter which we discussed about input root mean square voltage. So for we who are living in Tanzania, our domestic voltage or domestic root mean square voltage is 220 volt to 240 volt. So because we'll go in workshop, we'll measure. Usually used to range from 228, from 227 to 230 volt. But I don't want to say a lot or to tell you a lot. I think that you will measure yourself, you will know the amounts of voltage, domestic voltage by that time, because it's varying sometimes. But it cannot vary outside of this range. Are we together? Are we together? Another parameter, input parameter, so this we call them input parameters. Another input parameter, input parameters. Another input parameter is called, or we call it frequency. Say frequency. Say frequency. So what is frequency? Frequency is a complete number of cycles per second. Is complete number of cycles per. So we have to think about frequency because this is alternating voltage. It's alternating. So it has positive half cycle and negative half cycle. So when you have a positive half cycle of 180 degree and another negative half cycle of 180 degree, if you combine them, you have a complete cycle. Are we together? Yeah. So we say that the standard frequency of 220 volt to 240 volt is 50 hertz. Right? And then another parameter is frequency, or frequency is what it hertz. But also the standard frequency of 110 volt. 110 volt is 60 hertz. So in Tanzania, we are using 220 volt to 240 volt. So the input frequency should be 50 hertz. So it means the transformer that we are going to have, we are going to use, it can sustain the number of cycles. It can sustain 50 cycles, complete cycles, within a second. Go and wash your face. So now when you open, so it means that now when you open, this is step down, the block of step down transformer, it means we have to come up with the schematic circuit diagram. Or schematic, we call it schematic circuit symbol of the transformer. Because we've discussed what is being fed in the transformer, right? So then the next part is the structure. The representation or the architecture or the structure of the transformer. Okay? Then we discuss about what? Output. So, if this is the case, I think that another thing that you have to know. Yeah. So, I think that let us go there. So, the schematic symbol. Say schematic symbol. Say schematic symbol. This is the general schematic symbol of any transformer, whether it is step down or step up transformer. The schematic symbol of transformer is this one. So it means as transformer, it has primary coil and secondary coil. So also we have two types of step down transformer. We have non-centered step down transformer and the centered step down transformer. So this is primary coil. So what are we supplying? So actually we are supplying sinusoidal signal. What is its voltage? 220. Actually we can take 220 volt to 240 volt. But the frequency is what? So this is V in. The frequency is what? Is equal to what? 50 hertz. Then we expect it to have what? Output. So this one we call it figure. I don't remember the number of figure, but let us for the transformer. This is figure 1, A, which we call it non-central. Non-centered step down what? Step down transformer. So this is the symbol. These are just the parameters that we have written them, right? They are not a part of the symbol. Okay? So the schematic symbol of transformer, because I know, let me just clean this. The schematic symbol of transformer is just this one. Of non-centered step-down transformer. Non-centered step-down what? Yes. Oh, so the second, so for the centered, So you might find that, listen, for the centered, you might find that if this one providing 0 volt, this one providing root mean square voltage. I should not talk about this one now, but just wait a moment. Okay? Then we have what? So sometimes you might find the symbol of transformer, it has 3 bars. Should not be confused. Right? Because it depends the core. This we call it a core. This is primary coil, secondary coil. Simple like that. And this is inductor. Symbol for inductor, symbol for inductor. Symbol for iron core. Or ferromagnetic material. Then the second, for the centered, there is no limitations of the number of turns that should be 1, 2, 3, 4, 5, 6. No, you just decide. So you should not claim that. The number of turns in primary should be 5. You know, some students, they used to make sure that they claim everything. So even this one also still the same with this. Okay? And we know that in case of the step down, the number of primary turns should be greater than the number of secondary turns. In case of the symbol, that does not matter. Okay? So for the center, the step-down transformer, I say that every student has to write. Johanna, find a place that you have to write, because now you are slumbering. Every student must write. Find the paper, even write down. This is Tanzanian. Okay? So, with this one, for the center, the step-down transformer, it has 2 wires at the output. So this one we used to call it 0 volt always. This one we call it, we have root mean square 1. And this one also we call it root mean square 2. And this one we can call it root mean square voltage. And this one we call it 0 volt. So listen carefully. We did not discuss about the output parameters, but I'm trying to give you the overview. So this is figure what? If you do remember that when I've been teaching you about the transformer, I did not discuss. I just mentioned step down, and I just mentioned centered step down transformer and non-centered step down. I didn't go too much details. So this one, this is, you have to write that schematic symbol, getting symbol of 40 of non-step down, of non-centered step down. This is schematic symbol of centered tape. Sorry, here I forgot. Centered tape. Step down transformer. This is centered tape. Centered tape, step down transformer. So because of the limitations of our blockboard, you have to remember these blocks. So I have to clean them because we need some space to write more information. Okay? So let me clean this. You still remember that it's workshop 3. So let me clean this to have more space, because today I want to teach you the secret of linear power supply. So can I have those transformers? Urasa, give me 2 transformers, 2 different transformers. Just stand up and then collect them. So I need to show you the difference. But okay, wait first, Urasa. Let us discuss about the output. Then, the second output parameters, we have to discuss about output T, class output T, stand up, stand up. Every student has to stand up and stretch yourself. Same as stand up, stop. What are you? Output 40 parameters. Output parameters of 40. A step down translator, output parameters of step down transformer. So here we might focus, there are only three important parameters, but we might think about the other ones which I've mentioned. So let's mention them according to what? So this is the input of the transformer, and this is output of the transformer. So if we discuss about the input, the fundamental what parameters is input voltage, root mean square voltage, and what? A and frequency. But also you might think about the third parameter, which is what? The maximum voltage, but it's not a great deal. Yes, I think that we have to discuss about that before we discuss about these output parameters, because we'll need it especially in simulation. So the third input parameter is called the maximum or what? Peak input voltage. This one is not written on the top of transformer, but you have to know it sometimes because it might help you. Some of the simulation software, they don't give you an access to feed the root mean square voltage, because 220 volt to 240 volt is root mean square voltage. So some of the software or simulation software, they might give you a chance to feed the amplitude, where the amplitude is what we call T, maximum or peak voltage. And during simulations, I will show you. So what the symbol of maximum or peak voltage? A? That is the symbol of maximum or peak input voltage? Zuena? V peak. V with P as a subscript. Or V max as a subscript. That is what you forgot. So with this one, we say that the input, the maximum or peak input voltage, V, P of V maximum, and also the other one which you have to mention, and what? And peak to peak, because I know that you are electronics students, engineering students. Input voltage. So when we take you for analog electronics, you fail to understand peak to peak voltage. Peak to peak input voltage. So this one we call it VPP. Okay? So then it means that the maximum voltage relates to root mean square voltage. Right? So how? Simply we have to draw the graph of 40 of input of alternating input voltage. So this is voltage and this is time. Stop writing, stop drawing. Look. So here we have what? So this we call it V max or V peak positive, V peak negative. This is 0. Okay? So then we are going to have a sinusoidal. We might have a sinusoidal, we might have a triangular, we might have a sawtooth. Right? So this is V maximum. The V maximum is only single value. And then here we have what? Positive root mean square voltage. V root mean square voltage, positive. And here we have what? Negative root mean square voltage. Okay? Okay? So 220 up to 240 is root mean square voltage. Right? It's not maximum voltage or peak voltage. Okay? Okay? So then if this is the graph, remember also from 0 to peak, this also we call it in wave amplitude. So we might call maximum or peak or amplitude input voltage. In most of simulation software, if you'll pick an element or a power source that's called the alternator. They give you a chance to write the amplitude of the alternating voltage that you want. They don't give you a chance to write root mean square voltage. And that's why we taught you in AC theory of advanced secondary education. Right? Right?
Yes.
Okay. So again, another important parameter in electronics and communication is peak-to-peak voltage. So peak-to-peak voltage, when we've been discussing about the frequency, this is the period. If you do remember, here it's a period. So what is the relationship between frequency and period? It's 1/T. Right? And this is the one complete cycle. Positive half cycle, negative half cycle. But the distance from the from the positive maximum voltage or maximum point to the negative maximum point is this what we call the peak to peak. Are we together? Are we together, class? Okay. So I told you that electronics engineering can simply described in 5 parameters: numbers, formulas and equation, again what? Diagrams, what? Table of results, and what? Graphs. Right? So it means you have to learn this business in those 5 aspects. So now we have a mathematical relationship between these input parameters. The mathematical relationship is simple. V peak is equal to twice times V peak. So I think that let me just show the relationship. Joshua and Lucy and Mikidadi, you are doing a particular business for a long time. But that business began with what? Joshua and Lucy. So Mikidadi has been induced the magnetic field. Then Mikidadi acts as a secondary coil of what? Transformer. Mikidadi, do you see Glory? Concentrate like Glory. Oh, Digna then. Do you see that Eva? How serious is she? She's concentrating. So then the relationship is this one. We taught you in AC theory, alternating current theory, that we used to derive this formula. Root mean square voltage is equal to maximum voltage over square root of 2. Okay? Then maximum voltage is equal to square root of 2 times root mean square voltage. Are we together? So simple mathematical relationship. So remember that on the specification of the transformer, which I gave you, the value which is written on the top of the transformer, which as the input voltage, it's root mean square voltage. Are we together? Are we together? So now, if you want to know V peak, input V peak, so this is input V peak or V maximum. So we just calculate under 2, then same sort. Let us take 220 volt. So V maximum or V peak, what can you get after you compute? 300, 39, 28. And out of 2, Kankesha, is equal to what? 1.4. So 300, 39.20. Class, take your calculator if you don't know how to find the under 2. Four one, 4.1 volt. So this is the maximum voltage. But remember that this is also what we call amplitude. And I will show you when we go for simulation where we're going to use this parameter. For the time being, you might think that, I know that. Okay? Another, 240. There's no problems. If the input is voltage, you have to measure. If you go for in watts, you have to measure. If it is 228 volt, you just plug in this formula. So there's no need to have a but. We just took the standard. Huh? So according to the range, so V peak, if you have what? 100 times 220 volt is equal to what? Speak loudly, my dear students. Is that you are? I have more than 50 students in this class, but you don't hear even the ear voice. Speak it loudly. What do you get? My God. 3. Then mention the other one. 1. 1. 0.1. 1. Okay, 1. So voltage. So it means that the maximum voltage, V peak or V max of input, range from what? 11.1 volt. 1 volt or volt to what? To 339.41 volt. This is the range. Minimum range, minimum maximum voltage, maximum voltage. So this is what you have to note. So you might use either this one or this one. There's no problem. Then another parameter which we mentioned, peak to peak voltage. So peak to peak voltage is this one, from distance from here to here, which is twice from distance from here to here, right? So it means that if peak to peak voltage is equal to 2 times V peak. Okay? So peak to peak voltage of AC, not of the audio signal, not of the signal from the function generator. We are talking about alternating current. We are not talking about the signal. But the formulas are still the same for any sinusoidal signal. So this is the formula that you have to remember. So also this one is equal to, you can say 2. If you don't know the peak voltage, so you can say that multiplied by 2, then times root mean square voltage. So these are the formula which can help you to get V peak. But sometimes you might be given V peak voltage from peak to peak, right? Then you want to compute a V peak. So it's simple. So you have V peak to peak is equal to twice V peak. So V peak, which this one we call it amplitude, is equal to what? Is equal to V peak to peak over 2. That's the beauty of mathematics, because if you don't know mathematics, you might ask a lot of questions and might think that this is the new business. Engineering is tough because a lot of mathematics. Class, are we together? Is there any question at that moment? Things are clear. And you began to understand now V peak to peak and V peak. And you thought that it's a new terminology. So now, while I'm cleaning the blackboard, can you calculate the minimum V peak to peak and maximum V peak to peak? Yeah? So the range of V peak to peak is equal to what? Calculate V peak when the the maximum V peak to peak when the maximum when this is the maximum voltage, and then when this is the maximum voltage. Give me the range. 60? It's simple. You just take this one, multiply by 2. Why are you using a calculator? Yes, we take you 2 times 1. 2. 2 times 1. 2. Is there a need of using calculator? 2 times 1. 2. 2 times 1. 2. Tell your neighbor 2 times 2 is equal to what? Ask your neighbor 2 times 2. 2 times 1. Then 2 times 3, 6 volt to what? Then 2 times what? 1, 2. 2 times 4. Your neighbor say 2 times 2 is 2, eh? Yeah. 2 times 9, 18. Keep 1. 2 times 3 is 6. And that 1 is what? 7. 2 times 3, 6. Voltage. So this actually gives you a clear understanding of these concepts, regardless and without any limitation. So whenever you've been given V maximum, or you've been given root mean square voltage, or you've been given V peak to peak, you can deal. Right? So you can find what it has been asking for you to find. Because in signal generators, we don't have a space to fit the root mean square voltage. Right? In most of the simulation software, when we choose the alternator to present it the domestic power, we don't have a chance to change the root mean square voltage. We have only the chance to change the amplitude of that sinusoidal signal. Have you ever think why in signal generator there is no any chance for you to change, maybe to feed the peak-to-peak voltage or the root mean square voltage? Have you ever think why? You have never think why. The reason is the signal generator gives you different waveforms or different signals of the different waveform. It's not all the waveforms are sinusoidal. And it's not all the waveforms are cosinusoidal. Some of the waveforms are pars. So the pars does not have maximum, does not have a root mean square voltage. The triangular wave does not have what? The maximum, the root mean square voltage. That's the reason. Okay. I have clever students in this class. So, that is all about input, right? So then you have different values. But the important parameters for the input is just the root mean square voltage, maximum voltage, and frequency. Okay? Now we are going for the output parameters. So it's very simple for you to understand for the output parameters. Because we're still dealing with the same output parameters. So the first output parameter is a parameter called output voltage. Say output voltage. Say output voltage. So when you talk about the output voltage, we can talk the output voltage as output root mean square voltage. That's the first parameter. Okay? So listen. In electronics, we have different low power, step down transformer. Ask your neighbor, are you happy? Ask your neighbor, even online students, ask your neighbor, are you happy? So you say in electronics we have different low power step-down transformer that provide different root mean square voltage. So you say that the following are the standard output root mean square voltage of step down transformer. We have a step down transformer that can provide 60 volt. Stop writing and stop drawing. We have a standard transformer that is providing how many volt? Say 6 volt. The other one's providing 9 volt. Say 9 volt. 9 volt. Then the other one's providing what? 12 volt. Say 12 volt. 12 volt. But these are root mean square voltage. Right? The other ones provide 15 volt. Say 15 volt. 15 volt. Say 15 volt. 15 volt. Then 18 volt. Say 18 volt. 18 volt. Then 24 volt. Say 24 volt. 24 volt. And 48 volt. So these are the root. So it means the transformer itself, it's the one that providing root mean square voltage. You are the engineer. You have nothing to do for the transformer to give what you want. So when it has been manufactured, a transformer which can give out 60 volt, then can provide only 60 volt itself when you connect it to the domestic power. Right? Right? When you go and find a transformer 15 volt, when you connect to the domestic power, it provides itself 15 volt. You have nothing to do in order for it to give you 15 volt. Are we together? Are we together? Are we together? So you cannot find a transformer that can give you 10 volt. It's not there. Unless you design yours. It's acceptable. So this is the first one. So it means that these are some of 40 output, root, mean, square voltage. Then the second parameter is what? Frequency. If just you want to discuss about according to what we have discussed in input. So transformer has nothing to do to alter the frequency of the coil or the frequency of the alternating signal fed within it. So the output frequency, which is F, is still equal to 50 Watt? 50 Watt? 50 Watt? Half. But now you see the root mean square, it has been reduced from 220 volts to 240 volts to either 6 volt, right? Or what? 9 volt or what? 12 volt or what? Or what? Christina is not speaking. Frederick is actual outside the class. Or what? After 15 is 24 volt. 18? Or what? Or what? That, what the meaning of 48? Because you are just mentioning 48 volt, 24 volt, 15 volt. You don't understand what you are mentioning. Root, output, root, mean, square, voltage of the step-down transformer. Okay? Okay? Then the third parameter is what? Neema! The third parameter is what? Feedback. Maximum. Or what? Ever. AKA of maximum is what? Peak. Urasa. AKA of peak is what? Ask me, Pascal. Output. Maximum. Or peak. And what? Peak to peak. Because I want to strengthen you. Peak to peak. About the concept of peak to peak. Because he'll give you a lot of struggle. Output maximum, peak to peak. And peak to peak. Voltage. Voltage. So the principle is still the same. We have to say recall. We said peak voltage is equal to under root of 2 times what? Root mean square voltage. Right? Right? So for you to compute the peak voltage, you just need the output of the transformer. The output root mean square voltage of transformer, right? If it is 60, we have what? Under root of 2 times 60 volt. Jacqueline, what do you get there? If you multiply? Then, if you have a step-down transformer that providing 9 volts. So to get the maximum voltage, you just see, plug into the formula. Happiness, what do you get here? If you calculate this one? Who did I ask you to give me 6 times? Jacqueline, what the response? Jacqueline, square root of 2 times 6, because you've been discussing with Precious. Jacqueline is busy writing. She does not even listen what I'm asking her. It's what? 8? Speak loudly. Huh? Thank you. If it is 12 volts, it's 1 out of 2 times 12 volts. What do you get? 16.97, But the rest, you don't remember because you did not compute last time. Zuena, 9 times square root of 2. Where's your calculator? You don't have. You can borrow. 8.20? 18. This is the 18. Sonia was somewhere else. Kankesia? So you just used to carry a calculator during the examination time. Pili, 15 times 1 out of 2. Brighton, 1 out of 2 times 18. Brighton, is equal to what? Mugisha, VP is equal to 1 out of 2 times 24 volt. Nura, VP is equal to 1 out of 2 times 20 times 40. What? This is the last one. Give me the response. This one is for Jacqueline. My students don't want to calculate. Zuena. This is? This one. 12? 12.77 volt. So 73. Right? Next, because Jacqueline, she does not want to mention. This one 1 out of 2 times 15 volt. Pili. It is 21.22. 2101. 21. This one. That is Brighton. If you mention, you are Brighton. 1 out of 2 times 18. 5. 25. 25.20. 4. Okay. 460 volt. And this one. Abdullah. 1 out of 2 times 24 volt. That is Mugisha. 33. 33.20. 94 volt. Who can help Jacqueline? Seni? Jacqueline, 8.24. So now she decided to speak loudly. 8.48. Like this. Volt. So now you have the different or the maximum output voltage of different what? Step down what? Transformer. So you do remember that V peak is equal to what? Twice times what? So calculate the V peak of this point, calculate the V peak of this point, and calculate V peak. V peak. Here V peak. Then calculate V peak to peak. Because why do I tell you to calculate? This is the simple, or it's a very important practice for you to understand the relationship of these 3 parameters. Root mean square, maximum voltage, or maximum parameter, or maximum voltage, or maximum current, and the peak to peak. So calculate, my dear students. Don't relax. You have decided yourself to become an engineer. So there's no relaxation. So I mean you are not limited to pick any of those parameters of that transformer. This is transformer 1, transformer 2, you're not limited. The first parameter is called the output current. Output current. Say output current. Say output current. So mostly low power step down transformers provide output current range from 500 milliampere to 5 ampere. 500 milliampere to 5. So when you say that 500 milliampere to 5 ampere, each of these transformers that can provide any amount of power from within that range. Stop writing. Stop writing. Suppose that this is transformer 1, transformer 1, transformer 1, transformer 2, transformer 3, transformer 4, transformer 5, transformer 6. All of these 6 transformers can provide output current within this range. Are we together? Are we together? No. Who said no? Raise up your hand. How I said no. Thank you. I say, this is the range of output current that a transformer can provide. We have transformer number 1, number 2, number 3, number 4, number 5, number 6. These are the fundamental ones. So any of these 6 transformers can provide output current range from 500 milliampere to 500. There's no any relation to say that because this is providing root mean square voltage of 24 volt, it means it will provide 5 ampere. You can buy a transformer that provides 24 voltage, a root mean square voltage of 24 volts, but providing 800 milliampere. Right? So it depends to your choice and depends to your design. Because if your load that will be consuming this electrical power need or consume a total current of, let's say, 1 ampere, and they are using the step-down transformer of 500 milliampere, then the linear power supply will fail to power your circuit. Can I repeat? Can I repeat? The choice of the output current depends on the amounts of the current which will be consumed by your load or by your circuit. The total current, because the input unit will consume some amount of current, right? The control unit will consume some amount of current in order for it to work. The output unit may consume some amount of current. The communication unit may consume some amount of current. So you have to know the total current of your system before you choose the step-down transformer. Is it clear? Is it clear? If, for instance, the total amount of current that will be consumed by all of your system is 2 ampere, and then you are going to choose a step-down transformer of 12 volts that providing a root mean square voltage or root mean square current of 1 ampere, then your linear power supply will fail to power your system because your system needs large amount of current that transformer cannot provide. Are we together? Are we together? We are not together. If your load, the load or your entire system needs total amount of current of 1 ampere, and you have designed your linear power supply by using a transformer of 5 ampere, while your system just need to draw 2 ampere. For that case, your linear power supply will work and power your circuit safely, because it can provide the amounts of current required by your system. Is it clear? So that's why I'm teaching you these parameters, because they are very important. If you do a mistake, then you'll find that your entire system will not work. And you troubleshoot every electronics components and find everything is fine. But you forgot your choice of transformer is wrong. Dealing with currents is a little bit challenging electric parameter in electrical engineering and in electronics engineering and in telecommunication engineering. Many engineers are capable to deal with voltage rather than what? Current. Are we together? Are we together, class? Eh? So now, in order to make sure, or just to harmonize our design, we say that let us choose the transformer, or the step-down transformer, that provide output volt mean square voltage of 12 volt, and the output current, because we just need to power the amplifier, which will be just spending a few amounts of milliampere, output current of 40 of, let's say, 1 ampere, or let's say, okay, 500 milliampere, or let's say 1 ampere. Yes, 1 ampere. So for that case now, we can have our table of results. Okay? And our theoretical table of result. And then you can have the graph. Yesterday, so this is table 1, the table of result of 40 of step down transformer. So in this table of result, this is our electrical parameters. Remember that I'm adding the value, and here we are going to have measured, calculated the values, which we call them theoretical. And here we are going to have simulated values. And here we are going to have measured values. So this is the way our table will look like. So I'm adding the value. So it's quite different from what we discussed. I'm adding the value. Should you refer the previous table? It does not look like that. So the first, stop writing. The first parameter is what? Electric parameter is what? Anastasia? Anastasia is not in the class. Input what? Root mean square what? A. Root mean square voltage. What they calculated the values? So this is calculated by what? By the manufacturer. We said it's what? 220 volt. We may choose this one, or we may say that 240 volt. Right? Do we have simulated values? No, we don't have yet. Do we have Measure the values? We don't have yet. We'll measure it and fill that part. The next parameter, mention, because you have understood. Have you understood what I taught you? Eh? Today Latifa is not in the class. Emmanuel is sick. He asked me for permission. And because he used to attend my classes, most of them, I gave him the permission. I don't need even to confirm. Eh? Frequency? Frequency is not, actually does not change. The other one is what? A V peak or V maximum. What is it? 300? 26, 104. That one, right? So for simulation, we'll see it. Then the next parameter. Yes, Batty. Yes, let us put for frequency. Frequency is what? 50 hertz. Okay? This is how you have to think in electronics engineering. You should love numbers, you should love formulas and equations, you should love diagrams, you should love what? Anastasia? Tables. You should love what? Salama? Graphs. You love them? Do you have your graph paper? No, you didn't carry it. And next is what? Next parameter. Output what? Output root mean square. It is what? 12 volt. Next class. Speak it. This is input. Remember. Output maximum voltage. It is what? 16.20. Speak loudly. 97. 50 students, including yours. Then the next parameter. Output what? Current. What output current? 500 what? We said 1 in. So when you simulate the transformer itself, you have to make sure to get there. When you do measurement, you fail. You have never thought in this way, I know that, in engineering. Why you have never thought? Because you think that we use only to draw table of result in physics practicals. So in engineering, we don't have table of what? Result. So we are done with table of result, right? So you have to remember this table number 1. When you go for simulation, we'll fill the remaining column. When you go for the physical or hardware implementation, we'll fill the next column. Okay? So then another thing is what? Graph. Graphs of 40, step down, transform. How can we visualize graphs in electronics? How do you visualize graph of different systems in electronics? By using oscilloscope. But we don't have oscilloscope, which can observe the waveform of the sticky power. So this is 0. So this is V peak, but in. This is negative V peak, but out. V peak. So this is root mean square voltage. And this is root mean square voltage. negative, positive. So you have this is sinusoidal. Okay? Then here it's the output. So this is out. Positive. This is out. Negative root mean square voltage. So this is input. AC voltage. And this is output. AC voltage. So in engineering, we label tables on top of them. But we label diagrams and graphs at the bottom. So this is figure 1. The graph of 40. The graph of input. Input and the output AC voltage. Can I clean this part? Yes. So the last concept for this part is descriptions about center tapped and non-center tapped transformer. Theoretical descriptions about center tapped and non-centered transformer. Stop writing. The schematic symbol, we just have to listen and watch. Of center, of non-centered tapped transformer is this one, if you do remember. Hey! This is alternating signal. This is alternating signal. Okay, this is the non-centered step step down transformer. So listen, for the non-centered step down transformer, hey, Jacqueline, shift it to there. So if this one, listen, if this one for the, yes, it means that because the non-centered step down transformer, it has 2 wires in input and it has 2 wires at output. Can I have those transformers? Urasa? Can I have those 2 transformers? But also the output, it has 2 wires, in input it has 2 wires. There is no polarity for the output. There's no polarity also for the, there's no any polarity for output, there's no any polarity for the input. But if this transformer is written 12 volt, for instance, 12 volt, non-centered tapped step-down transformer, then it means that here, this one will be acting as a positive volt, and this will be acting as negative volt. It means that this one will be acting like a 12 volt, and this will be acting as 0 volt. It means if you measure the potential difference between this terminal of output and this terminal, you'll get 12 volt. Students, stop writing, stop drawing, listen and watch. This is non-centered step-down transformer. So I have them here. This is the example. No, this one. So this there, non-centered tapped step-down transformer. These 2 wires at the bottom are the one that we feed the input. So these are the 2 wires for the input. So these 2 wires representing, we have represent by using this coin. Right? Then these 2 wires representing what? The output. So if this is step-down transformer, because it has specification on top of it, is 12 volt. If you take the AC voltmeter and measure the potential difference between this terminal and this terminal, you get 12 volt. Are we together? If it is 24 volts, if you measure, you'll get 24 volts. And they have only 2 points to measure. So, still just stay thinking. Stay thinking. Let me take you to the centered step-down transformer. This is the schematic symbol of the transformer. Okay? So here we have another terminal. We have 3 wires at the output. For the centered tapped step-down transformer, we have 2 input terminals and they have 3 output terminals. Listen, Limi, and watch. For this case, if you find a step-down, this center tapped step-down transformer, it has been written, it provides the root mean square output, root mean square voltage of 12 volt. What does it mean? This is the meaning. If we measure, so this one will be acting as 0 volt. So if we measure the potential difference between the first terminal at the top and the second terminal, we'll get the readings of 12 volt. Also, if we measure the voltage, the potential difference between the second terminal and the third terminal, we'll get 12 volt. If we measure the potential difference between this terminal and this terminal, we'll get 24 volt. So when you say a center tapped transformer is just like this one. So these wires, which are the bottoms, are the input. So these actual are what you have presented here. And at the outputs, there are 3 wires. Right? Mostly you can find blue, yellow, and blue. Most of these wires are ready. Either ready, most of the input wires, red. Output here, blue. On this part, we have blue, yellow, blue. Yellow color is for F. True, yes? Then for this one, okay, so this is for the breadboard. So if you understood what are we say, what am I saying here? So for this one, we usually find that it's 12 volt, or we used to write that 12 to 0 to 12. Center tapped step down transformer. 12, 0, 12. What does it mean? 12 is this terminal. 0, center terminal. 12 volt, the other terminal. Are we together? Are we together? Are we together? In all the 6 standard transformers, we have non-centered transformer, non-centered step-down transformer, step-D transformer, and also we have what? Centered tapped transformer. Centered. Say centered tapped transformer. And also you have non-centered step-D transformer. Okay. So keep this. So if you need just a 12 volt, you have to use only those two terminals. If you need 12 volts, you may use either these 2 terminals or these 2 terminals. If you need 24 volts from the same transformer, you have to use this one and this one. That's the advantage of center step down transformer. It can provide you more than one root mean square. While for the non-centered tapped step-down transformer, you will just have only one root mean square voltage. Clear? Omolo, ask you a question. Hey. Pardon? Thank you for your question. He said that the ratings or the specifications on the top of transformer, you find that it's been written like this. So input voltage, you might find is 220 volt. Maybe frequency, they might write something 50 Hz. And then they can write the output voltage. They don't tell you that it's root mean square, but output, so you can write output is 12 volt. Then the output current, so output what? So let's say V out. They don't write this way. I think that there's a way that to write out. So it is 12 volts. So you know that that's root mean square voltage. Then maybe they can write out. Maybe it's 500 milliampere. So then his question is, if it is center, because these are the transformer with this specification can be either center tapped and also can be non-center tapped. Okay? So it means that centered stepped transformer is actual combinations of the two non-centered stepped down transformer. But the 12 volt written on the top of the transformer is just the voltage from here to here, or from here to here. Right? But if you measure the output voltage between this terminal and this terminal, it's 24. How do we get 24? It's 12 volt plus 12 volt. Okay? Okay, class? Is it clear? We can have a center tapped transformer of 12 volt, but it has 3 terminals. The first 2 terminals, 12 volt. And the second 2 terminals, 12 volt. But if you measure the first terminal and the last terminal, you find what? 24 volt. You can also have a non-centered step down transformer, which is rated 12 volt. It's only providing 12 volt. That's all. So in rating, we don't write, for this one that we have 24, we don't write 24 volt. Are we together, class? Okay, every student, check the photos of the transformers that you have taken. Take your mobile phone, check the photos on top of the transformer that you have taken. I say take your mobile phone and then check on the top. For instance, the one I have, this is the center tapped transformer, and specifications are written here on the top. This is the input, this is the output. So this is center tapped. Center, the difference between center tapped is just the number of wires at the output. If there are 3, center tapped. If there are 2, non-center tapped. Simple like that. Right? So the specification which have been written here, you see the name EI, then 57 times 40, 25. Then the next one, I/P, input / output. So this is input. So then we have what? AC 220 volt / with frequency of 50 Hz. Okay? I didn't tell you that to chat. I see some students who are chatting and watch what is going on WhatsApp. So then we have O/P. This means output. This is input, this is output. This is how we used to present information in electronics. Right? Eh? So for the output, this is AC 12 volt, then times 2. And this is 2.0 ampere. Okay? Then the other ones, or the other words, you'll find made in China. So we are waiting the one made in Tanzania. And the manufacturer is you. Tell your neighbor. We are waiting a step-down transformer made in Tanzania, and the manufacturer name should be you. Tell your neighbor, left and right. First of all, is your neighbor happy? How are you talking with somebody who is not happy? So with this information, Do you see? Yeah? So in this information, this is input, root mean square voltage, this is frequency. Maximum input voltage is not given, you have to calculate, you know the formula. Right? Peak to peak is not given, you have to calculate. Simple like that. For the output, this is AC, 12 volt. Times what? 2. The ampere or the current is what? Output current is what? 2 ampere. Right? Then this is the country where the transformer has been what? A has been made. So for this one times so, this is another indication to tell you that this is center tapped transformer. So you may draw 12 volt by draw it from the first wire. Let us label this is first, second, third. You may draw 12 volt when you connect the rectifier unit with terminal number 1 and the terminal number 2. Or you may get 12 volts when you connect the rectifier unit with terminal number 3 and terminal number 2. But also, if you need 24 volt, you may get from this from the same transformer. Right? Right? So how can you get? You just connect the rectifier with 12 volts with terminal 1 and the terminal 3. So the root mean square will be 24. But remember, the maximum voltage will also change. And all other information will change. Okay? Okay? So if it is non-center tapped step-down transformer, you won't see this multiplication side. You just see 12 and output. So this, you can use this linear, you can use this step-down transformer to design a linear power supply that can provide the currents of maximum 2 ampere. If your system needs 3 ampere and you design your linear power supply by using this transformer, then you have to know as engineer your linear power supply system will fail to power your system. Are we together? No. Think. Don't rush to ask questions while you have to take some time to think. So, the second block. Rectifier. I've tried my level best to teach you about step-down transformer. Those information, whether it is surface mounting, whether it's step-down transformer, we have in all kinds of the design. Whether it's through holes, we have them. These are the through holes step-down transformer that we find the large one. But you can have a small step-down transformer more than this one. And this is what we use often in portable adapters. Portable adapters. So the assignment or the task that I give you, when you go back home today or when you leave this class, you have to go and destroy the head of your adapter like this one and see what is within. So go and destroy. Yes. Hey, what? Go and destroy. How much does it cost you for this one? Even 5,000 you might get there. How much do you use to destroy yourself to feed your stomach? Minimally 5,000 per day. If now it's a matter of investing in your learning, if the matter of investing in your learning, then you can find that you see you are wasting money. Is it clear? So transformer matter in your design of linear power supply. The challenge we have, especially in your institution, students, they are not careful on choice of the transformer. And especially if the system that you are going to power needs or draw large amount of current, so large amounts of power, then you can find that you are designing, so you are doing all of your designing, and then you find that you are trying to test it, the power supply is not working at all. Okay, Eliakim has asked the question, when are you going to use the center tape D step-down transformer and the non-center tape D step-down transformer? You are the one who has to decide. If you can find the for instance, in your design, you need a 12 volt. You may either use a non-centered step-down transformer or a centered step-down transformer. Right? But against, maybe you need to use this one in another system that needs 24 volt. So for that case, you have to use the step-down, the center tape D step-down transformer. So the simple concept, you may use this or you may use this, depending on what you want. Okay? Okay? But if you have a center tape D step-down transformer, you have more advantage rather than having the non-OT. Okay? That's the only difference. Because if, for instance, you need, in one of your design, you need a 12 volt. And you need against 24 in another design. For the non-center tape step-down transformer, you need 2. Right? One that provides 12 volts, the other one provides 24 volts. Okay? But if you have a center tape step-down transformer, you just need 1. Are we together? So it means that a center tape D step-down transformer is a combination of 2 non-centered tape D step-down transformers. And you have to be careful. You have to be careful because when you measure the potential, because here you have the reference point. If you measure the potential difference between this one, the reference point is this one. This is the lower potential, high potential. Okay? When you measure the root mean square voltage between terminal 2 and terminal 3, the reference is this one. This is the higher potential, low potential. Okay? When you measure the potential difference between terminal 1 and terminal 3, one becomes higher potential, the other ones become low potential. Because what is the potential difference? Is a voltage between 2? Is a voltage between 2? You learned it in static electricity. You forgot that you've been dealing with this one? Negative voltage over 4 pi. You remember that? This is the electric field. So if your electric field, you multiply by what? You have forgotten. Electric field is equal to electric potential of what? So what do you remember? What do you remember? Jumper wire. You remember jumper wire? What the mathematical equation of jumper wire? So it is jumper is new story again. So for advanced, what do you remember? The names of the topic. That's you still remember. Mechanics, heat, wave and vibration, electrostatics, electromagnetism, and then from there you laugh. Current, electricity, then atomic physics, then electronics. Okay, so we are going for the part of 40, rectifier. Rectifier? 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 What the function of rectifier? To cross cut. Okay, so my dear students, this is all about workshop 3. I've taught you to design a linear power supply, and I've just opened the block of the step-down transformer. So we discussed a lot. Join me in the next workshop, which is workshop 4, where I'm going to teach you about how you can open the block of rectifier unit. Thank you very much. Stay tuned.